Welcome to the Crazy Hat Chemist. So another video here on intermolecular forces. So let's get moving. Bam! So today we're talking about liquids and solids versus gases. So the Kinetic Molecular Theory, or KMT for short, assumes that gas molecules are widely separated. Therefore, that means that there's a simple mathematical equation that is the ideal gas law. That's PV equals nRT, and this works because of that assumption that gas molecules are far apart and they have no intermolecular forces. And gases can be based on this simple set of assumptions. Gases are easy to explain, since one of the assumptions is that gas molecules do not interact. However, liquids and solids do have interactions between molecules. These interactions are called intermolecular forces, IMF for short. Okay? This partially explains the compressibility of gases. So 1 mole of water is equal to 22.414 liters. That's like about from here to there. That's a huge, gigantic box. The corresponding amount of 1 mole of liquid water would be 18 milliliters. And solid water would be approximately 18 grams. Okay? And solids and liquids relatively resist compression. Okay? This is a huge volume change because of the lack of intermolecular forces in the gases. Okay? So here's a diagram of a solid. Notice that there's a regular repeating array constantly. And there is a shape and there is a volume to a solid. It's independent of the container completely. Then we have liquids. And liquids are random. They're constantly moving and constantly in motion. Okay? And there is no shape, but there is a volume to a liquid. That is, it takes up the volume of its container. Gases have no shape and no volume. They take up the shape of their container and the volume of their container as well. And that's why they're really easy to explain, because you can see that those gas molecules do not have intermolecular forces. They're very far away from each other, and that makes the assumptions of the kinetic molecular theory very easy. Okay? Solids can also be described mathematically because there's a regular array of molecules and they are vibrating back and forth, but they do not exchange positions, unlike liquids. Liquids are actually the most complicated to describe mathematically because there is no shape, but yet there is a volume, and the molecules are exchanging places constantly. Furthermore, those molecules are interacting with gas molecules at the top of the surface, and they're interacting with the sides of their container. So all of those are different kinds of forces that must be accounted for, including of which are the intermolecules, the molecules that are inside, that are not touching the container or the gas at the surface. Okay, so in a liquid, the molecules are in constant motion. There is little order or structure compared to gases and solids. Therefore, there is appreciable intermolecular forces which must be either formed as a solid or broken to get a gas in order to change the state of matter. The molecules are relatively close together and very compact. Liquids are almost incompressible. Okay? Liquids do not fill their container. And the kinetic energy is proportional to the Kelvin temperature. I am the Crazy Hat Chemist. That was another cool, crazy video of intermolecular forces, and here's a crazy hat for you. Give me a thumbs up if you like that video, subscribe to my YouTube channel, and I'm going to see you next time for more intermolecular forces. Bye now.